what we're going to do is we're going to solve for a half parabolic problem. Now, half parabolic, that's not the actual correct definition of it. It's still a parabolic problem. We have an airplane that's going to drop a package, and the package is going to do a motion something similar to that. And if we want the package to hit right over here, obviously we can't drop it right above that because the package is going to go with the velocity of the airplane. And so what we want to solve for is we want to solve for this x of x. Where do we need to drop the package so that it hits in the spot that we want if we know two things? We know the x of y, or in other words the height up, and we know how fast the airplane is going. There are two formulas that you have to use. We have x of x, that's what we're trying to solve for, equals vi times the cosine of the angle times time. And then we also need to use this one, which is x of y equals vi times the sine of the angle times time plus 1/2 at squared. Let's put our numbers in. We don't know x of x. Vi is 40. Cosine of the angle. The angle to start with is going to be 0. That's pretty important. We're going to get into that in a little bit. Times our time. The cosine of 0 is 1. And so therefore, we can get rid of this and we just put 1. So x of x equals 40 times 1, which is 40, times time. We still have two unknowns in this one. What we're going to do is we're going to use this formula, solve for that time, to put it back up in our equation. We know x of y is 100. We know the vi is 40. The angle, again, is 0. We don't know time. Plus 1/2. We know gravity is 9.8. And there's our time squared again. The sine of 0 is 0. And so any number times 0 gives you 0. This whole part of the equation gets canceled out. So we can simplify it by going 100 equals 9.8 times 1/2 gives me 4.9 times time squared. Solve for time squared. It's going to be 100 divided by 4.9. Or in other words, time equals the square root of 100 divided by 4.9. Our time came out to be 4.51 seconds. What we do with that 4.51 is that we put that back up into this equation. So 40 times 4.51 back up. Second answer times 40. And we should get around 180.7 meters. What that means is that if we want the package to hit right here, and we're 100 meters off the ground, going 40 meters per second, we got to drop it 180.7 meters before our spot. And then the package should hit there. All right, what I want to do, that's relatively simple, not a whole lot there. But I don't like using two formulas and when you substitute one into another. And so what we're going to do is we're going to get rid of all this number stuff. And what we're going to do is we're going to solve for time using the formula and then put that formula up in here for time. As we said before, the sine of 0 is 0. So this whole part of the equation gets taken out. So we have x of y equals 1/2 a times time squared. We want to solve for time squared. So divide by 1/2 a, divide by 1/2 a. That gets canceled out. So we have time squared equals x of y over 1/2 a. Remember, a is 9.8, so half of 9.8 gives us 4.9. And to get rid of time, we have to square root it. So our formula comes out to be time equals the square root of x of y over 4.9. Put this up into this equation. X of x equals vi. The cosine of 0 is 1, so we don't need that. It gets rid of that. Times square root of x of y over 4.9. Let's put our numbers into it. X of x equals vi, which is 40, times square root of x of y, which is 100, divided by 4.9. 100 divided by 4.9. Square root that answer. Times 40. And we get 180.7 meters. So you have two options. You can either use this formula, or you can use both of these equations, solve for one another for the time, whichever way you want to go.